Hello and welcome to the last lesson in week 11, where we're going to look at applications. I'm able to write a function rule given a word problem and then be able to solve it. So writing a function rule, first thing we want to do is define two unknowns. Now we've defined unknowns before, but those unknowns we're looking at one variable. We used one variable, but there were the two variables related to each other. So we wrote one variable in terms of another variable. This time we're going to look at the input and output, and we're going to use two different variables. So it's going to be X and Y in the same word problem, whereas before it's always been just X. So here's an example. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. So the outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. So that's the relationship. So what are we going to do? We're going to write a function rule that represents this situation. So again, I just copied it down there. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. So write a sentence from this. Temp, so we're gonna shorten this down. We're gonna take the words and we're gonna shorten them down. Temp is 40 degrees more than 1/4 as a fraction chirps in 1 minute. Okay, so we're gonna look at that and you're gonna come up with what are the two things we don't know. Well, the first is the temperature. Let's let T represent the temperature. And N is going to be how many chirps are in 1 minute. If that changes, then the temp changes, right? So we're going to write now the relationship between these two things. T equals, so the temperature is equal to 40 more than is plus 1/4 is a fraction, chirps in 1 minute. So 1/4 times the chirps in 1 minute, which we don't know, that's N. There's my function rule. Okay. Example 2, you have $20 to buy milkshakes for your friends. Each milkshake costs $2.79. How much money do you have remaining if you buy 4 milkshakes? Well, you could figure that out if you had a calculator, right? How many milkshakes did you buy if you have $6.05 remaining? Again, you could probably figure that out. What could make those both happen a little faster would be if you had a function rule. So let's take a look. Let's define our variables. Let's first look at what's unknown. Well, we don't know how many milkshakes you're buying, right? And then the other one's a little bit harder to see. The other thing that is changing is the amount of money left after buying milkshakes. So those are our two variables. Well, how are those related? Well, the amount of money left, T, is equal to, well, what you started with, 20, and then subtract how much the milkshakes cost. Well, how much did the milkshakes cost? $2.79 times the number of milkshakes. And there's my function rule. So now I can answer the questions that I asked. How much do you have left if you buy 4 milkshakes? Well, 4 is the input. You bought, M is 4. So I put 4 in for M. I get 884. So 279 times 4, and then subtract that from 20, and you get 884. How many milkshakes did you buy if you have $6.05 remaining? Well, that's an output. $6.05 is a T value. It's the amount of money left. Okay, so I'm going to put that in for T, and then I got to solve that for M. We go back to solving equations here. We're going to subtract 20 from both sides, giving me negative 13.95. That's how much I've spent, equals negative 2.79 M. Divide by negative 2.79. The two negatives are going to cancel, and I come up with 5. So I bought 5 milkshakes, leaving me with $6.05. Okay, and that is what you're going to be doing today. You're going to be looking at a word problem, and you're going to try to make sense of it, figure out what two things are unknown, and then writing a function rule from it, and then using the function rule. So if you have any questions, please make sure you're reaching out. Good luck.